So we're going to start with number 11 and go all the way to 14 because that's what we did in class today. Make your little 1, 2, 3 chart. What that means is side, area, volume, to the first power, to the second power, to the third power. This is linear, this is squared, and this is cubic. So it's like the exponents. The very first word in the problem is volume. Volume means that I'm using cubic. So the 250 and the 16 are what go here. And you type that into your calculator, 250 divided by 16, and you'll get either a decimal or some strange number, and then you hit the math button and then enter, and it will reduce it for you, which is 125 over 8. So always reduce the fraction first on your calculator by typing it in, hitting enter, and then math enter. So because this time they gave us the cubic one, we're going to take the cube root of 125 and the cube root of 8. So our linear or our side ratio would be 5 to 2. And then I'll re-square those to get our area ratio of 25 to 4. So even though we figured out all 3 of those, we only need one of them. And how do you know which one you use? The next part of the question asks for area. So area means we're going to use the second one. So we don't even need this one or this one. We're only going to use the area because the problem is talking about area at the end. So 25 over 4 equals some other fraction, and it says the area of the smaller one is 16. Well, the smaller number's on the bottom, so I put 16 there, cross multiply, and solve. Alright, so let's try another one. Same idea here, number 12. Except this time it starts with area. So if the area is 16 pi and 9 pi, I'm going to leave the pi's off until the end and just put them back on. So 16 and 9 would go here. Now 16 and 9 is already reduced. If you tried to reduce it on your calculator, you would just get 16 9s right back again. So to take squared numbers and get them back to linear numbers, take the square root, so you have 4 and 3. Then you re-cube those numbers to get to the volume. You have 4 cubed is 64, 3 cubed is 27. So that is your 3 ratios: linear, area squared, volume cubed. Now let's see which one of those 3 we need. The next word in the problem is volume. So this one's backwards from the last one. We only need the third one. So we don't need that one and we don't need that one. So all I need is 64 over 27 equals the volume of the larger is 128 pi. So the larger is 128. That number is larger, so the larger goes here as well. Finishing up the problem, you have the answer is 54, but don't forget I took the pi off before, so I'm going to put the pi back, and I'm going to make it centimeters squared. Alright, same idea. The next one, number 13. The volumes of 2 similar cubes are 1000 and 125. So the volume is cubic, so that's why it goes here. You need to reduce 1000 and 125. And when you do that on the calculator, you get just the number 8, but 8 is really 8 over 1. So that one came out as a whole number, but obviously the denominator is 1. So then we take the cube root of this and put it over here. The cube root of 8 is 2, the cube root of 1 is 1. Then we re-square both numbers and we get 4 and 1. So there's our 3 ratios. Which one do we actually need? Area at the end of the problem. So we only need the squared area one, which is to the second power. So 4 over 1 equals the lateral area of the smaller is 150. Where's the smaller here? On the bottom. Cross multiply, you get x times 1. 150 times 4. It's 600 centimeters squared because we're asked for area. Alright, so the homework is assignment number 56, page 21, numbers 3, 5, and 7, which are these right here. And they're actually much simpler versions of the ones that we just went over, because if you look at the beginning of it, the ratio of the sides, you're starting with exponent 1. The ratio of the perimeters, those are sides, you're starting with column 1. The lengths of the sides, you're starting with column 1. So it's the same process with that little chart. It's just going to be a little bit easier than the other problems were before. See you tomorrow.